information, like you're trying to learn something new, but there's just so much out there.
Yeah, it's a common challenge, right? How do we even begin to make sense of it all?
Exactly. And it's not just us humans, right? It's a problem for machines too, especially as we're
Mm,
trying to build smarter, more sophisticated AI.
absolutely. At the heart of it all is this question. How can we design algorithms that are able to pinpoint and actually focus on the most important information?
Especially when you've got these massive, complex data sets to work with.
Right, precisely. And that's what makes this paper we're diving into today so fascinating. It tackles this very problem head on.
Okay, so what's the paper?
It's called Adaptive Subgradient Methods for Online Learning and Stochastic Optimization. Bit of a mouthful, I know.
Yeah, a little bit, but catchy.
Yeah.
So what's the gist? What are these researchers proposing?
Well, they introduced this really intriguing family of algorithms called AdaGrad. And the whole idea is to help algorithms learn more efficiently, more like how we might think about a human learning.
Okay, I'm intrigued. Learn more efficiently. How do they do that?
So traditional algorithms, they kind of treat all data the same.
Right.
Every piece of information gets equal weight.
Makes sense, I guess. But we know intuitively that's not really how it works in the real world, right?
Exactly. Think about it. When you're learning something new, you don't just memorize everything you come across. You naturally focus on the things that stand out, the things that seem most
The
important.
stuff that really grabs your attention.
Right. And that's kind of what AdaGrad is designed to do for algorithms. It helps them be more discerning, more selective in what they pay attention to.
Okay, so instead of blindly processing everything, it's like AdaGrad is helping these algorithms be more strategic, more targeted in their learning.
Precisely. And the key to this whole thing is something called adaptive learning rates.
Adaptive learning rates. That sounds pretty technical.
It is, but bear with me. Let me try to break it down. Essentially, it means that the algorithm doesn't learn at a constant pace. Instead, it adjusts how quickly it learns based on the specific information it encounters.
So it's like it's speeding up and slowing down depending on what it's looking at.
Exactly. And here's where it gets really interesting. AdaGrad is designed to give higher learning rates to features that are infrequent but potentially super informative.
Okay, so infrequent but important. I'm picturing like a rare book in a massive library, easy to miss if you're not careful, but potentially incredibly valuable if you find it.
That's a perfect analogy. It's like the algorithm is learning to sift through all the noise and zero in on those hidden gems, those needles in the haystack of data.
That's fascinating. So it's not just about the amount of data you throw at an algorithm. It's about making sure it's actually paying attention to the right data.
Exactly. And the paper actually delves into this idea using a really cool analogy.
Okay, let's hear it.
They talk about how, in a lot of real world data sets, the most predictive features might actually show up very rarely. Like those rare books in a library, they can be easy to overlook. But at a grade, it's designed to spot these subtle but crucial signals and give them the weight they deserve.
So it's all about working smarter, not just harder.
Precisely. And the really cool thing is they actually put this to the test.
Oh yeah, how so?
They used a massive data set called the Reuters RCV1 data set. It's this huge collection of news articles. And guess what? AdaGrad blew other algorithms out of the water when it came to accuracy.
Really? So this isn't just some abstract theory. This actually works in practice.
It does, and that's what makes it so exciting. The implications of this kind of adaptive learning go way beyond just, improving algorithms on paper.
It really makes you wonder what else is possible, right? If we can design algorithms that learn this effectively, what does that mean for the future of AI?
Exactly. And it even makes you think about our own learning processes, right? Like, what if we could train our brains to be more like AdaGrad, to be more adaptable, more focused on those needle in a haystack insights?
Now that is a thought-provoking question, something to ponder, for sure. But before we go too far down that rabbit hole, let's take a step back and look at some of the concrete ways AdaGrad is already being used in the real world. So AdaGrad is out there in the real world making things happen, huh? What kind of things are we talking about here? Where is it actually being used?
Well, one area where AdaGrad is really making waves is in the world of online advertising.
Online advertising. Really? I wouldn't have thought of that.
It makes sense when you think about it. All those ads you see online, they're not just randomly thrown at you, right?
Well, yeah, I guess they're tailored to my interests, at least that's what it feels like.
Exactly. And that's where AdaGrad comes in. It helps advertisers cut through all the noise, all the data about users and their online behavior to actually pinpoint the features that are most likely to resonate.
So we're talking about those needle in a haystack features again. The ones that are going to grab someone's attention and maybe even convince them to click.
You got it. And it's not just about showing you things you've already shown interest in AdaGrad. It can actually help predict what you might be interested in next, even if you haven't explicitly searched for it.
Okay, now that's getting a little too close to mind reading for comfort.
Hmm.
But I guess that's the whole point, right? To make those ads as effective as possible.
That's the name of the game. And it's not just about advertising. Either AdaGrad is being used in all sorts of fascinating ways in the field of natural language processing, or NLP for short.
NLP. Now that's something I've been hearing more and more about lately.
Right. It's all about getting computers to understand and process human language, which is no easy feat, let me tell you.
Yeah, language is messy, full of nuances and double meanings. Not exactly a computer's best friend.
Tell me about it. But that's where AdaGrad steps in and really shines. It helps refine those algorithms, helps them make sense of all that messy, nuanced language data.
So what are we talking about specifically? Give me some real-world examples.
Well, for one, think about machine translation. Those apps you use to translate between languages. AdaGrad is helping make those translations more accurate, more fluent.
So I can finally have that conversation with my Italian cousin without resorting to hand gestures and charades.
Well, I wouldn't go that far,
Yeah.
but it's definitely helping to bridge those language barriers, and it goes beyond just translation. AdaGrad is used to improve search engine results, making sure you're getting the most relevant information for your query. And yeah, it even plays a role in those AI-powered chatbots everyone's talking about these days.
Chatbots. So you're telling me that those eerily human-like responses I've been getting, that's AdaGrad at work.
Could be. It's helping those chatbots understand the nuances of your requests and respond in a way that feels more natural, more human-like.
I guess that's pretty impressive. But with all this talk about how great AdaGrad is, there have to be some downsides, right? Some limitations to what it can do. There's no such thing as a perfect algorithm, right?
You're absolutely right. No technology is perfect, and AdaGrad, for all its strengths, definitely has its limitations. One thing to keep in mind is that its performance can be really sensitive to that initial learning rate we talked about.
Right, the speed at which it learns.
Exactly. If that rate is set too high, it's like trying to learn a new language by cramming a whole dictionary in one sitting. You might miss those crucial subtleties and nuances.
And end up with a major headache in the process.
Pretty much. And on the flip side, if that rate is set too low, it might take forever to learn anything, like trying to learn a new language from just one page a day.
So it's all about finding that sweet spot, that Goldilocks zone where it's learning at just the right pace.
Exactly. And that often takes some fine-tuning, some trial and error to get it just right. Another thing to consider is that AdaGrad, at least in its original form, can struggle in what we call non-stationary environments.
Non-stationary. Okay, you're going to have to break that one down for me.
Sure thing. Basically, it means that the data itself is constantly changing. Think about something like financial markets. The factors that influence stock prices are constantly in flux. News events, economic indicators, even social media trends can all have an impact.
So it's like trying to predict the weather, only a million times more complex.
You're getting the idea. And in those situations, AdaGrad needs to be able to adapt to incorporate that new information on the fly.
Otherwise, it's going to be stuck using outdated information, making predictions based on yesterday's news.
Precisely. But don't worry, researchers are always coming up with new and improved versions. There are now variations of AdaGrad that are specifically designed to handle those non-stationary environments, constantly learning and adapting as new data rolls in.
So it's like it's evolving, becoming more sophisticated all the time, which makes me think about something you touched on earlier, this idea of adaptive learning. Not just for machines, is it? It makes you wonder if we could learn something from how AdaGrad adapts, how it processes information.
That's a really interesting question, and it's something we're going to delve into a bit deeper in just a moment.
It's pretty mind-blowing when you think
Yeah.
about it. All this talk about algorithms learning and adapting, it's almost like they're developing their own intelligence, right?
It's a pretty fascinating area to think about, that's for sure. And it really makes you wonder, what can we learn from how these machines are learning?
Exactly. Like, is there something we can take away from AdaGrad, something that can help us become more adaptable learners ourselves?
Well, one key takeaway for me is the importance of focus, right? AdaGrad isn't trying to process every single piece of information equally. It's selectively focusing on the stuff that really matters.
So it's like it's filtering out the noise and zeroing in on the signal.
Exactly. And that's something we can all probably benefit from, right? Learning to be more discerning about the information we consume, the things we give our attention to.
Absolutely. It's so easy to get caught up in the whirlwind of everything coming at us. But if we can learn to be more intentional, more focused, that's where the real learning happens.
Couldn't agree more. And the other thing that really stands out to me about AdaGrad is its adaptability. It's constantly adjusting, refining its approach based on the data it's encountering.
So it's not just about being focused. It's about being flexible, too. Being willing to change course when the situation calls for it.
Precisely. The world is constantly changing, and we need to be able to change with it. And that means being open to new information, new ways of doing things.
It's like that old saying, the only constant is change. We can either resist it or embrace it and learn from it.
Exactly. And I think AdaGrad, in its own way, is showing us that adaptation is key to not just surviving, but thriving in a complex, ever-changing world.
It's a powerful message, and it's one that I think we can all take to heart. Whether we're talking about machines or humans, the ability to learn and adapt is what allows us to grow, to evolve, and to ultimately reach our full potential.
Well said. And on that note, I think we've covered a lot of ground today. From the technical nuts and bolts of AdaGrad to its real-world applications and even its philosophical implications, it's been quite a journey.
It really has. A huge thank you to our expert for joining us today and sharing your insights. It's been an absolute pleasure picking your brain.
The pleasure was all mine. Always happy to talk shop, especially when it comes to such a fascinating topic.
And to our listeners, thank you for joining us on this deep dive into the world of adaptive learning. We hope you've learned something new, or at least had your curiosity sparked. Until next time, keep those learning rates high and stay curious.